young age, we learn that we have bones in our bodies, either by learning about them in school or, if you're unlucky, through the first-hand experience of breaking your arm or leg as a kid. But what is this soft stuff found in some of our bones called bone marrow? Why is it so important, and why do we need to learn about it? In this tutorial, we're going to look at the microscopic anatomy of bone marrow, as well as touch on its function and significance. First, we'll look at its location, that is, where bone marrow can be found in the human body. Then we'll move on to the major contents of bone marrow and their functions. We'll look at the bony framework supporting marrow and the vasculature supplying it. The marrow cavity is organised into 3 zones, and we'll look at how to identify those as well. Then we'll describe the characteristics of red and yellow bone marrow and discuss how bone is significant clinically. In adults, bone marrow is found within flat bones and the shafts of long bones. It's supported by a bony framework, filled with blood cells and fat tissue, and is the site of blood cell production, also known as hematopoiesis. We'll discuss hematopoiesis in more detail when we examine red bone marrow. Let's begin by looking at the structure of the bone marrow cavity at a microscopic level. Here we see a micrograph taken from bone, and what you can see highlighted in green is part of the network of bony trabeculae that fills the medullary cavity. Bone marrow fills the spaces between trabeculae. Marrow is mostly made up of very loose, fluid-like tissue and therefore needs support to keep its integrity. This support comes from the lattice-like network of bony trabeculae. Spongy bone tissue makes up this delicate network that is then surrounded by the hard cortical bone tissue you see when you look at the outside of a bone. Bones are highly dynamic. They change shape and size throughout your life and are heavily influenced by the endocrine system. Because of this, they must have an extensive blood supply. Arteries enter the bones through nutrient foramina on the surface and course through the bone tissue, ultimately reaching the bone marrow as small sinusoidal capillaries. We can see one small capillary here travelling through the marrow. These white circles are fat cells, and the smaller purple spots are developing blood cells. Although the tissue surrounding the capillaries is also filled with blood, the blood in the capillaries has a slightly different colour than the marrow. The purple cells of the marrow are mostly white blood cells and developing red blood cells. The capillary has mature red blood cells, so it appears more pink than the surrounding tissue. The bony trabeculae are also pink in this image, however they're much larger than the capillaries. Now that we've talked a bit about the support structures and nutrition of bone marrow, we can move on to look at how it's organised. Bone marrow is separated into 3 zones determined by their location. Let's take a look at how the zones are organised. The outer surface of bones is covered by a supportive double layer of connective tissue called the periosteum. This layer contains blood vessels, nerves, and progenitor cells that contribute to the growth of bones. Similarly, a layer of connective tissue called the endosteum covers the surface of the spongy bone trabeculae within the medullary cavity. The endosteal zone is a thin region of bone marrow immediately adjacent to the outer covering of bony trabeculae. The intermediate zone is an intervening region of bone marrow between the central zone